Hey everyone, and welcome back to the channel. Have you ever had this happen? You spend hours, maybe even days, crafting the perfect script. It runs flawlessly on your computer. You're proud, you're excited, you send it over to a friend or a colleague and nothing. It crashes and burns. They're using a Windows machine, you're on a Mac. Or maybe it's a different version of Linux. They get a cryptic error message, and you're left scratching your head, thinking, but it worked on my machine. What is this invisible force, this ghost in the machine that's causing all this chaos? Today, we're pulling back the curtain on one of the most crucial yet often misunderstood concepts in all of programming, the environment. This mysterious environment is the culprit behind that cross-platform conundrum, and understanding it is the key to writing code that works not just for you, but for everyone, everywhere. So what exactly is this environment? Think of it as a collection of invisible, unspoken promises your script makes. When you write a script, you're not just writing lines of code in a vacuum. You are implicitly assuming a whole bunch of things are already set up and waiting for you on the computer. Your script basically walks onto the stage and assumes the lights are on, the microphone is working, and the audience is seated. The environment is all of those assumed prerequisites. It's the collection of all the things your script needs to run, but doesn't explicitly bring with it. When you tell your script to use a specific tool or library, you're assuming that tool is already installed and ready to go. When you tell it to find a file in a certain folder, you're assuming that folder structure exists. These assumptions are the heart of the environment. Let's break down the key components of this invisible world. First up, and probably the most common culprit, dependencies. These are the external libraries, packages, or other programs your script relies on. For example, if you're writing a Python script to process images, you might use a library like Pillow. Your script assumes Pillow is installed. If it's not, the script will fail immediately. It is like trying to cook a recipe that calls for a special spice you don't have in your pantry. No spice, no dish. Next, we have paths. This is a big one. A path is the address of a file or program on the computer. On a Mac or Linux system, a path might look something like /users/your name/documents/file.txt. But on Windows, that same file might be at C users your name documents file. txt. Notice the different slashes in the drive letter? Your script might have a hard-coded path that works perfectly on your machine, but that path simply doesn't exist on another. The computer is literally looking for an address that isn't there. This is especially tricky with something called the system path variable, which is a list of directories where the operating system looks for executable programs. If a tool your script needs isn't in a directory listed in that path, the system won't find it, even if it's installed somewhere else on the machine. Then there are permissions. Your script is not an all-powerful entity. It's a guest on the operating system, and it has to follow the rules. It needs permission to read files, write to files, or execute other programs. On your personal machine, you're probably running as an administrator with full privileges, so your script can do whatever it wants. But when you send it to a server or a colleague's corporate laptop, it might be running with much more restricted permissions. If it tries to write a log file to a protected directory, the operating system will step in and say, "Nope, you're not allowed to do that," and your script will crash. Finally, we have the fundamental system differences themselves. We're talking about the deep-down architecture of the operating system. Windows, macOS, and Linux are fundamentally different beasts. They handle things like networking, memory management, and process control in unique ways. A command that works on one system might not even exist on another. For example, the ls command to list files in a directory on Mac and Linux is called dir on Windows. A script that relies on these system-specific commands is inherently non-portable. It's written in a dialect that only one operating system understands. The core problem is that our scripts are inherently optimistic. They just assume everything they need is already there, perfectly configured, just waiting for them. They assume you have all the dependencies installed, that all the paths are correct, that they have all the necessary permissions, and that they're running on a familiar operating system. When any one of these assumptions is wrong, the whole thing falls apart. The infamous "it works on my machine" problem is almost always a "my environment is different from your environment" problem. You're not just sending code. You're sending a set of assumptions. To make this crystal clear, let's use an analogy. Imagine your script is a high-tech delivery truck, and your code is the set of instructions for a delivery route. The environment is everything about the region you're driving in. It's the road conditions, the traffic laws, the location of gas stations, the type of fuel they sell, and even the language on the road signs. On your home turf, your own computer, you've built the perfect truck for the local conditions. It uses the right kind of fuel, it's the right height for the bridges. And your GPS is programmed with all the local roads. Your delivery route works perfectly. Now you decide to expand your business. You send that exact same truck with the exact same delivery instructions to a completely different country, a new computer, but you didn't check the local environment first. You've sent a truck that needs diesel to a country that only sells electric charging. Your instructions say to turn left on Maple Street, but here it's called Rue de l'Érable. Your truck is too tall for their low tunnels, and it requires a special permit to operate on their highways, which you don't have. The truck, your script, is perfectly fine. The instructions, your code, are logical. But because the environment is different, the delivery is a complete failure. The truck is stranded. This is precisely what happens when your script fails on another machine. It has entered a new region where the rules of the road, the paths, the dependencies, the permissions are all different. You can't just send the truck. You have to make sure it's prepared for the journey and compatible with the destination's infrastructure. So your script fails on your friend S machine because your roadmap was written for your local city, not theirs. You assumed the existence of a gas station, a dependency like Python version 3.9, but their city only has a station for version 3.7. Your directions mentioned a shortcut through Admin Avenue, but their city has that road gated off, a permissions issue. The failure isn't a bug in your code's logic, but a mismatch between your script's expectations and the reality of the new environment it finds itself in. The invisible world of the environment dictates success or failure just as much, if not more, than the visible lines of code you write. This leads to a fascinating and powerful question. If the problem is that our truck is incompatible with the new country, what if we could solve that? What if, instead of just sending the truck, we could package it up inside its own little self-contained bubble? A bubble that contains not just the truck and the instructions, but also a miniature version of its home city's roads, its specific gas station, and its local traffic laws? Is there a way to bundle our script together with its entire environment so that it runs exactly the same no matter where we send it? Could we create a universal, portable execution environment that we can ship anywhere? The answer is yes, and it has revolutionized modern software development. And that's exactly what we'll be diving into in the next episode. We're going to explore the incredible technologies that allow us to package our entire world, our code, our dependencies, our configurations into a single neat little box that can run anywhere. We'll be talking about concepts that let you say goodbye to the phrase, "It works on my machine forever." It's going to be a game changer, so make sure you're subscribed so you don't miss it. Thanks for watching, and I'll see you in the next one.